Hello, class, and welcome to Module 4. In this module, we'll be working with amines and amides. So the first thing I want to go through is the overview, objectives, and textbook reading preparation. So the overview, we will begin this module with learning about structure and properties of amines and amides. Then we will investigate their physical properties and structures. We will introduce IUPAC nomenclature for naming amines and amides, and we will conclude the module by analyzing reactions of amines and amides. The objectives. The student will be able to characterize structural differences between amines and amides. The student will be able to apply IUPAC's system for naming amines and amides. The student will be able to describe properties of amines and amides. And the student will be able to analyze synthesis reaction of amines and amides. So our reading is 20.4 in our chemistry book. And so I've already clicked on it. And so here it is. So here we're looking at the structure of our amines in this first part. And so if you look at our amine, the main portion that makes an amine its signature is this nitrogen group. Okay, so this nitrogen, it could either be attached to hydrogens and a methyl group. So this is methylamine. We can have two carbon groups and a hydrogen, or we can have three carbon groups. Characteristic in an amine also has that nitrogen with the lone pair. So it only wants to be bound to three other substances. So we're going to have that lone pair there. And then you can see here where we have a cyclic group, a cyclic amine. All right. And so those are some examples of your amines. Now I want to show you a reaction of an amine. So a reaction, so if we look at this first one, so this is all hydrogen groups. And if we add a hydrogen to it, we have an ammonium plus charge. All right. So remember I said that nitrogen likes to have that lone pair of electrons. If we add another element to the nitrogen, all right, and what it does is it shares those lone pair of electrons with an element. In this case, it's nitrogen. I'm sorry. In this case, it's hydrogen. That plus charge is over the entire molecule. So that's why we put the square brackets around the whole molecule and put that plus charge. Because nitrogen wants that lone pair of electrons. So if it's sharing them, then it's going to have a positive charge. So note that. All right, and then read through here. This gives you some science and how it applies to different things that we experience, like nicotine, morphine, codeine, and heroin. All of these are addictive drugs, and these are all amines. Okay. All right. So then now we look at our amides. With the amide, we still have the nitrogen, but now we add a carbonyl. So that is the main difference between an amine and amide, the presence of the carbonyl. And remember, the carbonyl is that C double bond O portion, all right? And so it's going to be attached to the nitrogen. So the carbonyl attached to the nitrogen is what you're going to look for when you're looking at amides, all right? And so on the other side of the carbon, the carbonyl can be other carbon groups. It could also be a hydrogen, like we see here. It could be either a hydrogen or an R group. Remember that R group represents carbon groups, and it doesn't matter how many carbon groups. That R just represents any number of carbon groups. Okay, so that C double bond O attached to the nitrogen, that's what you're looking for an amide. Now, the nitrogen can either be attached to hydrogen or it could also be attached to R groups. Okay. When you're doing the numbering, and you're going to see, I'm going to show you where the naming videos will be located. But when you're doing the numbering, that carbonyl carbon is always going to be the first carbon. Okay. And then you'll name your amide accordingly, but there are videos that are going to show that. In this chapter, it doesn't really go into detail of the naming. There are videos that are in the module that will go through the naming. This just gives you science and how it relates to everyday life for our means and our mids. It also gives you some examples of some synthesis reactions for our amides, just like we saw the synthesis for the amine. All right. And this deals with the proteins and enzymes. And so read through that information. It's really helpful. Kevlar, which is uh, um, polymer. Okay, and we use that for different products. Okay, the making of different products. But this is going to show you what that structure is. Anytime we're talking about a polymer, polymer is when we take one particular structure like this, and then we repeat it. Okay, and as you can see in this picture. All right, and then this gives you some examples of the usage of Kevlar. This table I wanted to go through because now you've looked at alkenes, alkynes, alcohols, ethers, aldehydes, ketones, carboxylic acids, esters, now amines, and amides. So these are all the functional groups that you have learned thus far. So this is just to give you a nice chart to keep all of these in mind, okay, and keep all of these together. This is going to help you because in this module, you will be taking your midterm. Okay, and your midterm is going to cover modules 1, 2, 3, and 4. And so this chart will help you refresh your memory so that you know. So if you're given a structure of an amine, it'll look like one of these, and you'll say, oh, yeah, that's an amine. Okay, or the structure of an ester or an aldehyde or an alcohol. So go through this chart. This was going to be very helpful for practicing being prepared for that midterm exam. And if you have any questions on any of these functional groups or structures, then please reach out to me and let me know. This also gives you some examples, okay, of the different functional groups. So go through these examples. Make sure you understand the different way that these structures are set up. Okay, we went through the Kekule, we went through the condensed, the line formula. So make sure no matter how that formula is drawn, that you understand which functional group it is, and also you understand the naming. If you don't understand any of these things, then please reach out to me and let me know. All right, so let's go to the next thing. So this is the supplemental online resources. These are those videos I was telling you about that's going to help you with the naming of amines. It's going to help you with the naming of amides. Okay. So go through these videos. They're going to help you tremendously. As you can kind of see from this picture, it's going to go through the numbering for your amines. It's also going to go through the numbering for your amides. The other thing that is helpful in each of these videos is looking at how the reactions are for the synthesis of the amines and the mids, all right? Because you're going to look at that for the lab portion of this module. You're going to look at the formation similar to what you did in Module 3, where you looked at the synthesis reactions. You're going to do the same thing for Module 4. So go through those videos. Make sure you listen to them, take notes. That's going to help you as well with the midterm exam. All right. Then we have an activity. This is kind of a fun activity where you're matching the functional groups, all right? And so this is called Ketone Crush Organic Functional Group Matching Challenge, all right? And so you want to it's an understanding organic functional groups is essential for recognizing chemical structure, predicting reactions, and identifying biological molecules. In this activity, you will strengthen your ability to recognize family or organic compounds by completing an interactive matching game. Okay. And so here's the link for the game. I'm gonna go through the game itself, but I want to go through the learning objectives. So you want to identify common functional groups for organic chemistry. You want to match the molecular structure to the compound family, distinguish between ketones, aldehydes, esters, alcohols, and relating compounds. So this is not only for amines and amides, but it's for all of these. That way, it's a good practice for the midterm exam. All right, so we're going to open it. And it says you want to match the chemical structure with the correct organic compound family. You want to continue until all matches are complete. At the completion, you will receive a performance medal. Okay. The board changes each time so you can replay the game to improve your score. What you want to do is take a screenshot or photo clearly showing the completed game board, the final score, and your medal that you earned. All right. And so then you're going to submit it. This is the way the points go. So if you get platinum, okay, then you get 20 points. Gold is going to give you 19, silver 18, and copper 17. And your picture submission is going to be 5 points for a total of 25 points. So let's look at the game. All right, so here's your game. So when you're doing the game, you are moving these around. So this right here, this shows that ketone is this structure, all right? But you're going to move these around so that you can make matches. So let me show you. Let's actually play the game so you can see it. And this is a pretty fun game. So the more you play it, the better your score, all right? And the more practice you get for preparing for the final. And so you see that they're all kind of moved around. So you can move this around. You can move it up and down. I don't, oh, you can go diagonal. Um, So this is how you can move them around, all right? Because you are making matches next to each other, okay? You're not making matches up and down, but they're next to each other. And so, say for example, this right here, this is an alcohol, okay? Because you have that OH group, but it is a primary alcohol because it's attached to that first carbon. Primary alcohol is down here. And so we want to get it next to here. Okay. So you see how I moved that around so that I can match it. Okay. So you get 10 points. So once that has been set, you cannot move them individually. They move as groups. All right. So if I move that over there, see how it moves as a group? All right. So that's just to let you know. So play around with that. All right. And once you've finished it, it'll give you a medal. All right. And then it will, it'll say complete, but basically all of these are going to light up. So you want to hit print screen and you want to, okay, I think, did I do it right? Print screen. There it goes. And then you want to highlight this. Okay, so you want the whole thing highlighted. And then it's going to give you, once you've highlighted, it'll give you a picture that you can copy and paste into the submission box. And let me see if it'll show up for me. Nope, it won't. All right, so in yours, you'll have a submission box. You're going to paste it directly into the submission box. All right, and then that will be for your grade. So let's see what is next. And then let me know if you have questions on that. So you do have a homework for this one, 10 multiple choice questions. There's no time limit. You do have 2 attempts. If after your first attempt, okay, you don't do as well as you want to do, remember, don't do that second attempt until you fully understand the material. So you may want to go back and review the material on amines and amides before you do your second attempt. The homework questions for modules 1 through 4 are going to give you a good way to study for the midterm exam. So make sure that you fully understand. Also, another thing that is good to study is the labs because the labs go over the synthesis and also the drawing of the different structures. All right, so the Module 4 lab, we are working with the means and emits. Like always, you have here your link for the printable version. All right, and so this is your printable version. And so it goes through looking at the synthesis of our amines and our amides. So if we look at this particular example, we are looking at the formation of our amine. And so we have our, our acyl chloride. Sorry, my it was a tongue twister for me. So this is our acyl chloride and our nitrogen. Remember, we have that lone pair of electrons. So that lone pair of electrons is going to go to this carbon, okay? And as you can see here, I'm going to actually make this a little bit bigger so we can see what's going on with these arrows. So the electrons from the lone pair are going to come and combine with the carbon. Okay, and it's going to form a bond. All right, as we can see here, we form a bond between the nitrogen and that carbon. Remember, I explained before that anytime we use those lone pair of electrons to form a bond, we have that plus charge for the nitrogen. So that's what we see here. The Also, we see that this carbon used to be a double bond with the oxygen. It is now a single bond with the oxygen, which makes it a negative charge on the oxygen because that bond adds lone pairs. It's not shown here in this picture, but that bond goes to the oxygen and it forms lone pairs, which makes it have that negative charge. Now, but we are not forming a bond with that carbon. What we want to do is form our um our compound, excuse me, structure of our amide. And so the lone pair of electrons from the oxygen goes back to form that double bond. Because remember that C double bond O attached to the nitrogen group, that is what makes this an amide, all right? But we don't need this chlorine. Okay, that's not part of it. So the chlorine is going to leave, all right? And it becomes Cl minus because that bond adds lone pair of electrons, which is not shown in this picture, but that's what gives it that negative charge. And the nitrogen still has its positive charge because it has 4 bonds now, all right? So that is the mechanism for the formation of the amide. So now we're going to take that amide because we want to form our amide as well as our amine. Okay. And so we are now going to have this lone pair of electrons from another amine, okay, come in, and it's going to take this hydrogen. When it takes the hydrogen now, it forms this compound, which remember, it now has 4 bonds, so it has a plus charge. And so the bond between the nitrogen and hydrogen here are now going to reform the lone pair of electrons on the nitrogen, and so it no longer has that positive charge. So this is the formation of our final amide, okay? If you have questions on this formation, all right, let me know on the mechanism. So what you're going to do is you are given your compounds that you are reacting together. You're going to draw the Kekulé structure and you're going to mark how the electrons are transferred and then get to your final product, okay? And you're going to name your product, right? Then you're going to write the complete reaction. Use this as your guide, okay? So use this as your guide on where the arrows are drawn, all right? If you have questions, though, let me know for that one. So you're going to do that, and then you're going to do your post-lab questions, all right? So you are doing just one structure, all right, for this particular lab. You're only doing one structure, which is your amide, all right? But if you have questions, you're going to let me know, all right? Because you want to make sure that you understand the synthesis for your amide before you take your midterm exam, all right? So I strongly suggest that your midterm is the last thing you do for this module. And you want to make sure that you thoroughly understand the material because for your midterm, you only have one attempt. All right. It is 20 multiple choice questions. It is 50 minutes to take it. So make sure that you are paying close attention to your time. You're going to work through modules 1 through 4 for this midterm. So make sure that you understand the material. I can't stress it enough for modules 1, 2, 3, and 4 before you take your midterm exam. All right. And if you have any questions as you're going through this particular module, and as you're preparing for your midterm, if you have any questions, please let me know. All right, enjoy this module, and I will see you in Module 5. Have a great day.